AC electrical motor generally divided into two main categories. 1. Synchronous motor and 2. Asynchronous motor. An asynchronous motor is popularly called as induction motor. An induction motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. An induction motor can therefore be made without electrical connections to the rotor. A synchronous electric motor is an AC motor in which, at steady state, the rotation of the shaft is synchronized with the frequency of the source current. The rotation period is exactly equal to an integral number of AC cycles. In this video, I will discuss the major differences between a synchronous motor and induction motor. Induction motor's construction is simpler, particularly in case of cage rotor. Synchronous motor's construction is complicated. An induction motor is a single excited machine. A synchronous motor is a doubly excited machine.
Induction motors are the most commonly used electrical machines. They are cheaper, rugged, and easier to maintain compared to other alternatives. In this video, we will learn the working of a three-phase squirrel cage induction motor. It has two main parts, stator and rotor. Stator is a stationary part, and rotor is the rotating part. Stator is made by stacking thin-slotted, highly permeable steel laminations inside a steel or cast iron frame. Winding passes through slots of stator. When a three-phase AC current passes through it, something very interesting happens. It produces a rotating magnetic field. To understand this phenomenon much better, consider a simplified three-phase winding with just 3 coils. A wire carrying current produces magnetic field around it. Now, for this special arrangement, magnetic field produced by three-phase AC current will be as shown at a particular instant. With variation in AC current, magnetic field takes a different orientation as shown. From these 3 positions, it's clear that it's like a magnetic field of uniform strength rotating. The speed of rotation of a magnetic field is known as synchronous speed. Assume you're putting a closed conductor inside it. Since the magnetic field is fluctuating, an EMF will be induced in the loop according to Faraday's law. The EMF will produce a current through the loop. So, the situation has become like a current-carrying loop is situated in a magnetic field. This will produce magnetic force in loop, according to Lorentz law. So, the loop will start rotating. A similar phenomenon happens inside an induction motor also. Here, instead of a simple loop, something very similar to a squirrel cage is used. Three-phase AC current passing through stator winding produces a rotating magnetic field. So, as in the previous case, current will be induced in bars of squirrel cage, which is shortened by end rings, and will start rotating. That's why it's called an induction motor. Electricity is inducted in the rotor by magnetic induction rather than direct electric connection. To aid such electromagnetic induction, insulated iron core lamina are packed inside the rotor. Such small slices of iron make sure that eddy current losses are minimum. This is another big advantage of a three-phase induction motor. It is inherently self-starting. So, you can see here that both magnetic field and rotor are rotating. But at what speed will the rotor rotate? To obtain this answer, let's consider different cases. Consider a case where the rotor speed is the same as the magnetic field speed. Since both are rotating at the same speed, the rotating loop will always experience constant magnetic field. So, there won't be any induced EMF and current. This means zero force on rotor bars. So, the rotors will gradually slow down. But as it slows down, rotor loops will experience a varying magnetic field. so induced current and force will rise again, and the rotor will speed up. In short, the rotor will never be able to catch up with the speed of the magnetic field. It rotates at a specific speed, which is slightly less than synchronous speed. The difference between synchronous and rotor speed is known as slip. Rotational mechanical power is transferred through a power shaft. In short, in an induction motor, electrical energy is entered via stator and output from motor. Mechanical rotation is received from rotor.
A simple three-phase induction motor is shown in figure. Three-phase induction motor faults and their causes. Generally, two types of induction motors are used in our industry, such as wound rotor and squirrel cage rotor, but their faults are almost same. Here we have classified these faults in three types, but these are further subdivided. Number 1, electrical faults. Number 2, mechanical faults. Number 3, environmental faults. Electrical faults. These faults are further subdivided into 7 types such as single-phasing fault. Single-phasing fault is occurred when any one phase of supply voltage is getting lost, because 3 phases voltage supply is must require for normal working of 3-phase induction motor. Due to this fault the motor could be burned or heat up. Reverse phase sequencing fault. Reverse phase sequencing fault is occurred when any one phase of 3-phase voltage supply is reversed. Means the phase order of supply voltages are swapped. Due to this fault the direction of rotation of motor has changed. Under or over supply voltages fault. This fault is occurred when supply voltages are under or over the specific limit. The limit of 3-phase AC supply voltages is 380 to 440 volts. So when supply voltages are crossed this limit, then motor could be burned or heat up. Overload fault. This fault is occurred when motor is overloaded. Means the higher load is connected at output side of motor. And due to this load motor could be heat up or excessive vibration. Earth fault. Earth fault is occurred when any one phase of supply voltages is connected to the housing of the motor, then motor is totally shorted. In this condition when anyone will touch this motor then he will feel the heavy shock. Beside this, the motor would take over current that could be dangerous for induction motor. Inter-turn short circuit fault. Inter-turn short circuit fault is the such type of fault when two turns of same phase or different phases are short circuit. During this fault the motor could be totally damaged, or coils of that specific phase could be damaged. Crawling fault. Crawling fault is basically an electromechanical fault in 3-phase induction motor. This fault is occurred when motor is fully loaded with full supply voltages, then it does accelerate but it runs nearly 1/7 of its synchronous speed. This specific phenomenon of induction motor is called crawling. Mechanical faults. Mechanical faults are such types of faults which are generally occurred in internal housing of 3-phase induction motor. These faults are further subdivided into 3 types such as broken rotor bar fault. The squirrel cage induction motor consists of rotor bars and shorted end ring. If these bars are damaged or partially cracked, then this type of fault is called rotor broken bar fault. There are so many reasons for occurring this fault, but it has mainly observed that this fault is occurred due to manufacturer defect. Because during brazing process non-uniform metallurgical stress may occur in rotor bars which may lead the rotor bars failure during the rotation of rotor. Broken rotor bar fault is shown in figure. Rotor mass unbalance fault. If we concentrate on the construction of induction motor, then we can easily know that the rotor of induction motor is placed inside stator bar, and it rotate coaxially with stator. In heavy motors, it is centrally aligned with stator, and its axis of rotation are also same with the geometrical axis of stator. So the air gap between inner of the stator and outer of the rotor is same. Similarly, if this air gap is not same, then the situation which is referred to eccentricity would be occurred. In this eccentricity situation, the rotor fault would be occurred, that is called rotor unbalanced fault. Bearing fault. in three-phase induction motor, two sets of bearings are installed inside of motor housing, for the supporting the motor shaft. The main purposes of these bearings are, to rotate the motor shaft freely and reduce the friction. They consist of an outer and inner ring which is called races and a set of rolling elements which is called balls. The balls are fixed in an inner and outer side of ring and they reduce the friction of shaft. The friction could be further reduced by the lubrication of these balls. Sometime the balls, outer or inner ring of bearing is damaged due to any physical problem, then the fault is occurred. This fault is called bearing fault, and due to this fault, the motor totally jammed or struck. Motor bearing fault is shown in figure. Environmental fault. In three-phase induction motor, different faults could be occurred simultaneously, and, in these faults, environmental fault is also so much important. Induction motor surrounding environment such as ambient temperature and moisture etc. affect on the performance of induction motor. These factors reduce the performance of induction motor. Beside this, the vibration in induction motor that could be due to any reason such as, not properly installed, also affect the performance of induction motor. So during the installation of three-phase induction this factor should be kept in mind.